Hi, I'm Tanish, and this video is going to be about the basics of probability, part 1. This video is going to be on sample spaces, theoretical probability, and in theoretical probability, there's going to be a complement of an event. Quick note, you're going to have to know combinations for part of this video, so I have another video on combinations. If you want, you can check it out. I have the link in the description. Here's a few vocabulary terms in probability. We have the probability experiment, an action or trial that has varying results. We have outcomes, possible results of a probability experiment, event, collection of one or more outcomes, sample space, set of all possible outcomes. Let's use these vocab words on this example. You spin the spinner and flip a coin. List all the possible outcomes. The possibilities for the spinner ranges from 1 through 4. It goes 1, 2, 3, 4. The possibilities for the coin is either heads or tails. So it's heads or tails. So it could be 1 heads, 2 heads, 3 heads, 4 heads, 1 tails, 2 tails, 3 tails, and 4 tails. We can check that by using the fundamental counting principle that we learned in the previous video. If you haven't learned that already, you can check the description for that video. There are 2 possibilities in this for the coin, and there are 4 possibilities for the spinner. 2 times 4 is 8, and that's exactly what we've got. Now let's use this example for the vocab words. Right, a probability experiment, where that is basically a trial that has varying results. This here would be a probability experiment because the outcomes from this are different. It's not absolute. Outcomes are the results of a probability experiment. These are the results. So each individual thing is an outcome. Event is a collection of one or more outcomes. Let's say the event of a coin being heads, that could include this one here, this one, and this one. So all of these things would be the event that the coin is heads. Let's say the event that the spinner is 1. Then this one and this one is if the event that the spinner hits 1. So let's say if the spinner hits 1 and the coin is heads. So what is the, let's say that's the event, then what's the specific outcomes? So there's only one outcome for that, and that'll be 1H. So that also is an event, even if it has one outcome or more outcomes, that all constitutes as an event. A sample space is the set of all possible outcomes, and this right here would be the sample space because these are all the possible outcomes. Theoretical probabilities. Alright, these definitions are just like some of the more basic understandings of just what general probability is. Probability of event is the likelihood that an event will occur. Favorable outcomes are the outcomes of a specific event, clearly the event we want to talk about. When all outcomes are equally likely, the theoretical probability can be found by the favorable outcomes over the total outcomes. This is basically the probability of a coin landing on heads is 1/2 because there are 2 outcomes, right? There's 2 outcomes, right? It can either be heads or tails, and we only want the heads, so it's 1/2, so it's 1/2. Let's solve this problem. What is the probability of getting a sum of 3 when rolling 2 6-sided dice? So a way to solve this is to add all of the possibilities and see which ones add up to 3. So we have to add 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and see which ones add up to 3. Alright, that's this probably not a good. Honestly, brute forcing it doesn't seem fun. You just have to keep on adding 36 times. Let's be smart about this and figure out how to solve this. Because when you come to much more tough probabilities, you're gonna have to think more so that you can find the probability much faster. So let's be smart about this. Since all of these are positive integers, right? Then we adding a positive integer to another positive integer will only make it more positive, a higher number, right? So if we were to add 6 plus another positive integer, Is there any way we could get 3? No, there's no way. Same goes with 5, 4, 3. 3 there's no 0, so we can't really add 0 to 3. So we're gonna have to cancel that as well. So 3 plus any other number would just be more positive. So let's cancel those numbers because there's no way that the sum could equal 3 at all. And we're left with 1, 2, 1, 2. And if we solve that out, it'll be 2, 3, 3, 4. We found 2 3s over here. And if we did add all of them, since there were 6 numbers here, 6 numbers here, 6 times 6 would be 36. So that 36 different possibilities when you add two 6-sided dice, right? So that's the total possibilities that will go underneath 36. And what would go over is the favorable outcomes. So the favorable outcomes is the 3s. And since there are 2 3s, the 2 goes on top. So this would be equal to 1 over 18 are drawn from a deck of 52 cards. What is the probability that all 3 cards are red? Alright, it's favorable outcomes over total outcomes. So let's do the total outcomes first again. So since there are 52 cards and we have to choose 3, randomly draw 3 cards, um, it's obviously going to be 52, choose 3, because when you draw those 3 cards, it doesn't matter in which order you draw them, you'll anyway have the same cards. Then we have to choose the favorable outcomes. What's the possibility that the 3 cards are red? So in a normal deck of cards, half of the deck is red and half is black. So there are 26 red cards, and from the 26, we choose 3 cards. And that would be our favorable outcomes, right? That's what we want to happen. Out of the 26 cards that are red, we want to choose 3. So from the 26, we want to choose 3. So it'll be 26, choose 3. This is our probability. And if you solve it out and simplify, the answer would be 2 over 17.